5 minutes then. John, Julia, sit down. All right. Before we begin the next concept, we're going to take a quick look at the outline page so you can point some stuff out.
Don't tell me you're going to put the homework on headline.
No, don't do that like Miss Jenkins.
No, like only on headline?
No. Relax, guys, relax.
Yay.
So, the reason, let's not talk about that now, Jason. Let's talk about us. The reason I'm showing you this now is because I found a way to put your SAT online math class at the top always. So you know how we're starting the online class for SAT, and I said you're going to have to hit more info and go down to the bottom?
Yeah.
Okay, so this will always be at the top. Okay? Now, when you click on here, what you're going to see for you guys right now is just week 1. That's this week already. And what you're going to be seeing every week is the same thing I have on my computer, and I'll show you right now. What I have is this. This is my folder, and I have all the weeks planned for you guys already. So every week we're doing a different topic, a different thing. There's different homework assignments. So if I went into week 3 of mine, we're going to be starting a chapter called Chapter 1, and you're going to be doing some practice homeworks and stuff. So everything that I have, I'm just going to simply copy and paste onto Edline. So you're going to see my folders. Now, the simplest way to go about this course is to use the syllabus. Okay, and the first thing you're going to see in week 1 that's already here, oops, not the normal curve fitting I didn't want, is the syllabus down at the bottom. The first class I'm going to record today during probably 4th or 5th periods and seniors are out working. That's what I'm going to do every week. Either I'm going to record, on Friday beforehand so you guys can see it by Monday, or I'll record on Monday. Now, I started using YouTube instead of the Vimeo site, which seems to be much better. You can track along the whole thing. It buffers much faster. You don't have to worry about there being 3-minute jumps like Vimeo had. Like you couldn't go back like 10 seconds. If you moved it a little, it would skip 2 minutes. So again, I didn't realize that. So I fixed whatever it was on YouTube to enable more than 15-minute videos. That's all it was. So I had it's not even advertisers. No, you just have to give information about yourself. That's it. They ask for information. They ask for your phone number. Literally, that's it. And then you can have more than 15-minute videos. Just Google how to have longer than 15-minute YouTube videos, and it's simple as anything. You go through like 2 steps. It's like, give your phone number. I'm like, okay, I have a Google phone. I'm on Gmail. Everything I have is connected to Google. So you have my phone number already. So it didn't make any sense at all to me why I was doing it. That was literally all.
You're in charge.
So today what I'm going to do is I'm probably going to spend about 30 minutes in today's video. And what I'm going to do is I'm going to go over the overview of the whole course, how to follow the syllabus, and the idea of normal fitting, okay? Normal curve fitting for the scores. And I talked about it real quick, where 500 is the average, 800 is the max, 200 is the min, and we have that normal bell curve I had showed you. But I'm going to go over that again and give you statistics based on previous tests. And a lot of the stuff that I'm using today, a lot of it, there's a lot of good online resources. So you're going to see different things I pulled from different sites, different documents. Okay, and again, all of them are just advertisement things. They're all based on free, they're open source, so you can use any of their PDFs and stuff. So I see a lot of tables. So I'm just trying to give you simple examples of how you can go online and make your own, in a sense, SAT course if you navigate the web the correct way. So I'm going through different topics and pulling stuff from different locations. Sample questions from here, ideas from this one, reference tables from this one, explanations from here. It's very simple to do that, okay? Especially with the capabilities you have today. When I was younger, I barely had, our modem was still dial-up. So call, dial phone number.
Oh, yeah.
And we didn't get one until I was in 12th grade. And it would dial up, and you'd have to wait for a minute or 2, and then you could get on. And click one page, you'd wait 45 seconds. You sat there, you had a book, and you waited 45 seconds. It's true.
I remember that, yeah.
You did. That's exactly what. AOL Instant Messenger barely existed. That wasn't even a thing. Now it's not even heard of. Do you guys even use Instant Messenger anymore?
I don't even use AIM anymore.
Nobody's heard of it.
I heard of
Every little disc.
Yeah, they always send that.
Whatever, it's cool. So, the other thing you want to look every week is the following. Ready? Miss? If you look at the actual syllabus, so let's take a quick look at it. If you look at the syllabus, you're going to see every week is planned out here. Now, if we, hold on, let me change the hand tool. Or not. That's a 9. If we look at the syllabus, if I pull it up this way instead,
So weeks from now, the 13th.
alright, sorry, looking at
13th.
the project is due the 13th, yes. Remember, the final portfolio is due the 13th, yes. So if we look at the first week here, we're going to see, I'm going to do simply an overview, okay, an overview which includes the syllabus and the general idea of the course and types of things in the SAT, and then the normal fitting. Your homework during week 1 is going to be all 4 of these activities here, not just one. Okay, again, every week I'm going to give you a different thing to follow up with. So, for example, I want you to read all the math vocabulary. There's a document. So, see how you see 4 of these bullets here? See how you see 4 of these bullets here? If you go to the web page and you look and you go back to Edline, you're going to see that under homework. For now, you're going to see probably just 3 of them here. Good. There's only 3 of them. The 4th one is the practice section that I want you to do. What I've decided, just to save paper, guys, is I'm not going to print them out every week. I thought about it, and it really is going to kill like a lot of trees if we do this. So I'm thinking, we're talking like 6 pages of paper per person per week, 80 students. So that's a ream of paper a week, just to like have the accessibility of having it. So when I put the actual section in, so again, your homework, if we go back and take a look, your homework is to read math vocabulary, is to complete a math vocab quiz with the answers too. They're there, so you can check the quiz afterward. All of this is self-assessment, which means that for everything that you have, you're going to have an answer key to also. So for example, complete math vocabulary quiz. After you complete the quiz, you're going to see the answer key. And for the most part, there are detailed solutions to everything that is on there. So explaining step by step how to get the answer if you didn't get it correct. Okay, or alternate ways. There's a lot of documents I'm going to use are going to be documents that are not only solutions by teachers, but student solutions also. So there'll be like a student solution and then a teacher solution, they'll say. Like students will use a method like picking numbers or trying numbers, whereas a teacher might make 2 equations and solve simultaneously. Okay, so you'll see different solutions. Based on where you are, it might help you look at one or the other, or for everybody to look at both. John?
Since what's in the SAT for math is the same thing as the ACT.
Except there's trigonometry on the ACT. I have an ACT document also, a few of them actually, that summarize it really well if you want to see it. When do you guys take that?
Like 2 days.
Like 2 days?
11.
Okay, so you know what I'll do? Under SAT folder, I'll share the 2 or 3 ACT documents. They're like 20-page documents. I didn't make them myself. I got them from another source, but you're welcome to read them. They summarize it really well.
I don't trust them anymore.
Guys, if I read something and I provide it to you, I usually don't just provide it without reading it myself. So if I'm going to provide something, then you have my faith that it's a good document, that it's not something that I would just give you for no reason. Okay, I'm not going to give you like crap work or material that's not good, understand? So, again, you're going to read the math vocab, you're going to complete the math vocab quiz, check your answers. Now, there's another document that has math formulas, all the formulas that are given to you, a sample, and then how you can use them. So another page of where you would use this formula, where would you use this formula. So you'll see that's a 2-page document only. And then the last thing is to complete a practice section. Now, the practice section will look like the following. The practice section will look like this. Give me a second to pull it up so you can see. This is like a sample of what a practice section would look like on the SAT. Okay, these are like the formulas you're given here that you're going to see the document that explains. This will be the practice section. Now, when you are practicing, you're going to notice, and I'll explain this, some sections have grid in. Half of it is multiple choice, half is grid in. You've seen it on the PSAT. Okay, so this is a grid in. So when you keep your answers and stuff, you're going to have either multiple choice or a grid in. Okay? Please, 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 keep your work. Don't just write down A, B, C, D. You know what you guys need is this. You know what you really need is a binder or a notebook, whatever you prefer, because I don't care at this point. I'm not seeing it. If you want a notebook and you like notebooks, that's fine. But you need a notebook or a binder to keep all of your work. So at the top, you would write. This would be, for example, practice section 1. This is what you're going to see. At the very top of your notes, practice section 1. All of your answers. Then you know what, afterward, when I post the solution, you check all your answers and correct them all on there. If you do this every week, it's going to become a very simple thing to do. When you get to the test, you're going to be so much more comfortable with it that alone will increase your score. I'm serious, guys. A lot of people have trouble on these tests for just simple test anxiety. If you do enough of these, it's like second nature. Okay, just like if you do daily assessments. I'm not saying they're easy all the time, and I know some people struggle with them. But at least you have the idea down. You're used to it by now. It's not a weird thing to say, oh, we have a quiz the first thing in the period, because you expect it every day. It's routine. Okay? It'll become the same if you continue to practice this.
So, if we do these practices a lot, how much will that raise our score?
John, I'm not a fortune teller. It's not. There's no set number. John, some people do SAT courses and raise their score 200 points. Some do them and raise it 10 points. I took an English course and went down 10 points. So, yeah, I took an English course. I tried to improve my English score and I went down 10 points.
Oh,
Whatever.
I'm sorry.
Oh yeah, you know what? This stinks. But I didn't do my work. I know for a fact. Every week I would cram the 10 minutes before my meeting with my tutor, and I didn't do any of the actual work. And I realized that afterward. I wasted all the money. I paid for it myself. My parents didn't pay for it. But it was $500 I paid. I paid for 10 sessions. It was $50 for half an hour. $50. I did. You know, but I learned a lesson. It was a big waste of my money. I knew that, but I had to learn my own lesson. Anyway, so again, guys, starting today, please don't do all this stuff on the weekend, even though you know you have a 3-day weekend. Like, for example, your first assignment for the SAT class is to read the vocabulary. Okay? Just read it yourself during the week. Because I'm talking for a reason, not to hear myself talk, it's for you to listen to. Read the vocabulary when you get a chance during the week, okay? Make sure you get to these tests during the week. If you really can't and you have to wait till the weekend, that's fine. You do it that time. But try not to wait till Sunday night. It will become a really bad habit. Okay, you're going to rush it. You're not going to do as well. You're going to skim, and you know what a lot of you are going to start doing? And I know I'm guilty of myself. You're not going to take the practice test, and at the end of the week, when the solution comes out, you're going to read the solution and say, oh, I read it. It's okay. I know how to do it because I read it. But you know what? It's not even close to the same thing. It really isn't. I've read so many solutions, but you don't learn something until you can do it yourself. Okay? So repeating my solution in your head 20 times, reading it over, is not the same as actually strategizing and going through the process and the thought process that is involved in this. John?
So, don't wait till Saturday.
Yeah. Just don't procrastinate. And we're all guilty of it. We've all done it before.
I mean, it's not procrastinating because we have a whole bunch of other work to do, so...
I understand. Guys, all I'm saying is spread it out, okay? Please, please, please spread it out. Okay? Start with the vocab worksheet, read it tonight maybe. Then you look at the vocab quiz tomorrow night. Then you read the formulas the next night. Then you take the 20-minute practice section. 20-minute. Time yourself. That's all you got to do, guys. It's not a lot of time. Okay? This one, actually, I'm sorry, this one might be 25. I apologize if it is.
That 25-minute section for...
This one is 25. There's 25, 20, and then 25, so it alternates. English has the same thing.
Can we save that section then for the weekend?
If that's what you want to save, then you save that, sure.
Okay.
But again, guys, I'm going to post the solution to this on Friday at the end of the week. So you're going to have the solution to this document available, which is very tempting to just look at it and not do it yourself. So doing it before Friday might be a good suggestion. Again, on Friday, I will post the solution to this document. All right. And now we begin. On your homework, there was one general question I got from every class. So please take a look at number 6, please. Number 6 on your homework.
Oh, yeah. He always buys you stuff.
Quickly, take a look, quickly. Number 1, the answer. I'm giving the answers real quick, guys, if you want to see, if you want to check your answers. Here's how I'm giving the answers. I'm giving the end behavior on the left first, and then on the right. Understand? So I'm giving the as it goes to negative infinity for x, and then as it goes to positive infinity for x. So for the first one, you're going to have, it's going to look like this. I'm going to show you with my arm. So you're going to have a negative infinity on the left and a positive infinity on the right for number 1. Again, I can sketch it very simply actually each time to make it easier for you guys. This is a graph that looks like that. So negative infinity on the left, infinity on the right. Number 2, it's odd and it's positive again. So it's the exact same thing as the previous one. Again, it's to the 5th power. You got to look at the highest term, not the first one. Remember, you always go to the highest degree. So this is in one that looks like this. That's what that one looks like. It's got an extra hump in the middle of it. Okay? You're going to notice that if you put an x-axis, you would see 1, 2, 3, 4, 5 roots because it's x to the 5th. Okay, so this one is the exact same end behavior, same exact ones. Okay, as the first one. Julia.
I put all these pages or whatever.
In the calculator. You can do that to check, yes.
It didn't show that. It just showed.
It might have just looked like this, Julia. It might not have had all those movements, or it might have even looked really not steep. It's possible. I'm giving you general shapes. Again, based on the behavior of the numbers, so see how it's 8x to the 4th? If that were a negative and maybe this 7x were 7x squared, it would change the shape, and it might look like the first one. I'm giving you the general ideas. Okay? All right. Third one, the highest degree is even, and it's negative. So I think of a parabola opening downward. Again, negative, negative, even, think of a parabola opening downward. So both sides are negative infinity. Okay, again, this shape might really look like this. Might look something like that. Or it might look something like this. I mean, the shape changes. It's going to be a curve. Sorry, smooth curve. But the size of each one can change. Okay? Next. Number 4. It's linear because I see it's x to the 1 right here. Are you okay? It's a negative leading coefficient, so the line must be going down. That's what a negative slope means. So it's a positive infinity on this side and a negative infinity on this side. Okay, again, as x goes to negative infinity, or to the left, y goes to positive infinity. As x goes to positive infinity, or to the right, y goes to negative infinity. Next one. Somebody give me the answer for the next one, please. It's squared, and it's positive. So what do you think of? What shape? Good, infinity, infinity. What shape is that called? Parabola. Very good, Brendan. That is exactly right. That's the shape we're looking at, people. So we got positive on both sides. Next one. Many people got stuck with. It's a line. Just solve for y, please. So solving for y. I get 2y equals 6 plus x. I divide by 2. I get y equals 3 plus 1/2 x. Look at the leading coefficient. It's 1/2. Here's your leading coefficient. The power is 1. So it's a line and it's positive. So I got negative on this side and positive on this side. Okay, again, it's a line and it's positive. The 1/2 is the leading coefficient. And the last one is number 7. And I can't see it yet, and you are right, Julia. It is negative, negative. It's a parabola. Negative, negative. So if you guys keep up this good work with the homework, it'll be going a lot smoother, guys. This is very good. Your last cognitive assessment was awesome. There were 17 people, 16 people with 4s for the last concept. There were 6. Yeah, you did. There were 16 people with 4s for concept 30. Relax, please. Relax. Hopefully it's the same for the ones today.
What do you mean I didn't finish?
Now, before we begin, you guys please start writing this. I'm going to pass out your it's the only thing I'm going to print for you for the online SAT course is the syllabus. Okay, so you have this. So here's the syllabus I just showed you. Please copy the problem on the board. Let's go. That's one back.
Here, what do you mean share?
That's one back.
Short 14 pages.
You wrote 8. You wrote 14.
How many did you write?
You wrote 14.
She probably got cut off.
She didn't get cut off.
Oh, yours?
Oh,
No, it is due today.
Yours?
How many pages is yours?
Not that. It was 7 pages. The actual thing. It's probably 8 with the citation.
Guys, you got to write this stuff down. Let's go.
Wait, I thought you just got cut off. No, tomorrow's the 3rd. February.
Oh. No, March 31st.
Oh, there is a 3rd. Oh.
Guys, we're starting in about 30 seconds. If you're not ready, you're not ready now. Let's go. Can't ask 4 times.
Sorry.
you looked at the notes last night that I posted, you'll see that I tried to do a bit of a color coding for the first one. Okay, so just look at it carefully. You'll see what I did. What we're really doing today is we're simply going to do 2 problems. That's it. Okay, 2 tough problems though. Not tough as in difficult to think about, but tough as in there are a lot of steps in both the problems. So you have to make sure that you are constantly rechecking yourself, looking for small errors, making sure that you don't have negative signs switched up. That kind of stuff comes to play here a lot. It's not conceptual errors that people make, but it's silly mistakes they make. All right, so today we're going to look at operations with polynomials. We're going to be adding and subtracting and then multiplying. We will not be dividing today. Dividing is a whole other process with polynomials. Okay, and we are going to use that synthetic table that we started using, that L-shaped table that we used on concept 30 for synthetic division, which will be our next concept though. It's not going to be in this one. So first we're going to look at adding and subtracting polynomials, and I wrote simply just think combine like terms. That's it. Whenever you're adding or subtracting, all I want you to think about is combine like terms. Now, example 1 says, suppose that f of x is the function 2x cubed minus 5x squared plus 3x minus 9, and g of x is the function x cubed plus 6x squared plus 11. Determine the value of f of x and g of x, or the sum of f of x and g of x, and the difference between g of x and f of x. Notice I'm using the word sum of and difference between. Those are other ways that you're going to be able to see this on your SAT. So if you didn't know what the word sum of meant, and it meant plus, write the sum of f and g. Or for part B, write the difference between g and f. The difference between g and f. Okay, you're just translating, but you're going to continuously do this kind of stuff. So you have to make sure you're thinking about that as you do your problems. So the sum of f of x and g of x. So simply look at f of x, look at g of x, and combine the like terms. Go ahead, try it on your own. I'm not even going to go into it here. You should all be able to do this like that by now. Multiplying is going to be a little bit trickier, but adding and subtracting there should be no question about it. This is an Algebra 1 topic that we're quickly reiterating. Again, like terms, and simply what I'm doing is exactly what you should be doing in your mind. Again, just correlate the exponents. That's all you're doing. Anything that's cubed, you add it together. Anything that's squared, you add it together. Anything that's linear, or just an x, meaning linear, you add those coefficients. And any constants, you simply combine them as well. Can I get a hand to see an answer for this one, please?
Okay.
A hand and a mouth. Go ahead, Jay.
3x to the third plus 1x squared plus 3x plus 2.
Plus 3x plus 2?
Yeah.
Thank you. Okay? Again, just simply look at the different exponents and combine them. That's all we're doing here. Good, Jason. I got the same thing. Everybody agree?
Yeah.
Okay. Second one. Now, who remembers concept 1? Concept 1. What is the definition of subtraction? Add the opposite. Very good. So simply do that, please. What I want you to think is this. Before you go anywhere, is do this. Rewrite this as g of x plus negative f of x. In your mind, think of it that way. Okay? Trust me, guys. Trust me. It will be such a simple method. I do this every time. So take g of x, switch all the signs of f of x, and then combine them by adding again. So add again. Don't subtract. But just switch all the f of x signs in your mind as you add. Okay? Or simply write them on the paper. Rewrite the signs for each of them. Check. Yes. Some of your signs are off.
3 minus. 3 minus 6.
It's -3.
Negative
Yeah.
5. We got 5 minus 6.
-5 minus 6.
Okay, you're negative.
Oh.
Negative 11.
That should be negative.
Would that be 1 or -11?
That should be negative also. Three again.
-5 minus.
Use your calculator.
So that's not right. Remember I said-
-11, right?
I'm
No.
trying to figure out where I get.
Look at the way I'm teaching you. Daniel, if you do it this way, and you simply switch all these signs in it, make that a positive, make that a negative, make that a positive, make that a negative, and then combine adding, you won't run into that error.
So
Try it.
execute.
Switch all this, literally rewrite them if you have to.
Try 10.
-11 squared, yeah.
20, very good. All right, if you do this, if you do this, here's what you will see. You're going to have g of x, which is x cubed plus 6x squared plus 11, plus, now, again, I'm simply going to switch all the signs in f of x, that's it. Negative 2x cubed plus 5x squared minus 3x plus 9. And now combine like terms. Okay, it's much easier to do it this way. You can do it the other way, it's fine, I don't care, I'm just trying to give you a suggestion. Okay? As long as you're able to do it correctly. If you can't do it correctly, then you might need to switch or try something new, please. So your final answer for this one would be negative x cubed plus 11x squared minus 20, I'm sorry, minus 3x plus 20. Uh-oh.
It's flickering.
You see that?
That's
That was
fine.
weird.
Might be the
Okay.
light.
Are we good with adding and subtracting? All right. Example number 2 now. Example number 2, there's a lot of writing to do. Okay? There's a lot of writing. I'll dictate, okay, to make it easy so you don't have to look up. Just keep writing. I'll start now.
Alright, let's get it.
First, the topic is called multiplying polynomials. Okay? There are 2 methods to do this. You don't have to write word for what I have up there. I'm summarizing for you. There are 2 methods to do this. Box method or distributive law. Box method or distributive law. Okay, that's the instructions at the top that I just gave you. Next. Example number 2. Example number 2 I'm going to read word for word because I made this problem up and I think this is a good representation of what you might see on an SAT. Example 2 says, if, now I'm going to name a function, if I of t, capital I of t, represents the current function, current being electricity, the current function, and r of t, another function, represents the resistance function, find the expression that represents the voltage function comma, and then the equation is written here, V of t equals I of t times R of t. Those are all the functions that we just listed. Again, the voltage is equal to the current times the resistance. If, again, that was V of t equals I of t times R of t. If I of t, now I'm going to give you the definition of I of t. If I of t is equal to 2t cubed plus 4t minus 6, and R of t is equivalent to t cubed minus 2t squared minus 5. That's the end of your first sentence. There were commas in there that I didn't dictate.
Misplaced modifier.
Then find the current. Let's not talk about that. Then find the current, resistance, and voltage at 2 seconds. Then find the current, What's so funny? The resistance and voltage at 2 seconds. Now, again, the question is asking us to find the voltage function by multiplying the other two functions and then evaluate them at a certain time, time equals 2. So, we're going to determine the voltage function using both methods. We're going to use the method called box method, and we're going to use the method called distributive law. And we're going to use both of those methods. Then, we will figure out the current, resistance, and voltage at 2 seconds. So, in order to do this, what I've done is simply looked at, I've simply written a way to verbalize what you're going to be doing for box method and for distributive law. You all know box method already, so you really don't need this. Okay, but I just came up with my own definition. I said, make an n by m grid. You don't have to write this if you don't want, if you know how to do box method. Make an n by m grid, where n is the number of terms in one of the functions being multiplied, and m is the number of terms in the other function being multiplied. So make a box, same way we always do it. Multiply row headings by column headings, and then combine like terms that exist in the grid. So, many of you have seen this before, so I'm going to make a grid like this. I'm going to say t to the third here, negative 2t squared here, negative 5 here. Again, that's my resistance function. Along the headings, I'm going to use my current function. My current function. So I'm going to have 2t cubed, 4t, and then a negative 6. And again, I have box method now. I highly recommend, my personal opinion, that you use box method here. Distributive law is real messy. Okay, box method is tough to write on a computer, so I'll use distributive law a lot on the computer, to be honest. But by hand, please use box method. Okay, please use box method. Now, just simply match up your row and column. Okay, multiply this heading by this heading. Here's your box right here. Again, so if I multiply this heading right here times by this heading right here, I will end up in this box right here. And you've all seen this before with binomials, but now we just have a trinomial. So we'll have 9 terms to add together instead of 4. If we had, instead of a trinomial, we had, let's say we had 4 terms, there's no word for it, but let's say we had 4 terms, and then a polynomial. 4 by 4 means that we'd have 16 entries to add together at the end. So 5 by 3 would be 15 entries. Just multiply them. Common sense. So here, t to the third times t to the third is t to the sixth. So simply add the exponents. As always, please add the exponents. And then multiply the coefficients. 2 times 1 is just 2. Please, please, you can't be making mistakes here. Okay? We have to add the exponents, and multiply the coefficients. The next line, I'm going to have t squared times t to the third, which is t squared times t to the third, t to the fifth. Okay, thank you. One step at a time. Thank you, Victoria. Now, continue. Negative what?
Negative 4.
Negative 4, good. One step at a time. The last one. Do you have any t in the 5 part?
No.
There's only a negative 5 by itself here. There's no t. So you know what? If there's no t there, then we don't have to change the exponent of t. This t cubed remains t cubed. And then I have 2 times negative 5, which is negative 10. Again, if there's no t there, you can't multiply by anything. So then just multiply the constant coefficients or the constants. Now please try the next 3 or next 6 entries on your own. Fill those in. Then afterward, you can combine all the like terms that you see. I'll give you about 30 seconds to start, then I'll start filling them in so you guys can check. 30 seconds.
He said he's
Have you seen one of these down?
he should be working.
Mr. How that was in 30 seconds?
That was
Does it
at
really
least
matter?
30 seconds, John. Jay?
Why are you trying to get that doing your work?
John Jay.
Well. How you? Alright,
So we call it Jennifer next.
I never understood box methods. What do you call it? Once you get out of them?
Combine like terms.
Danny. Oh, and I understand the weekend.
Please check your box. Now,
Yeah, I got.
what you have to notice is the following, people.
Oh, negative. Oh, yes.
Many textbooks make problems that work out perfectly every time. Your functions are not always going to work out so that it's easy to combine like terms or it's simple when you see the answer. Now, usually the diagonals are the ones that you can add together if you can add anything. Now here, you'll notice, as Juliet just said, we have a t cubed over here, we have another t cubed right here, and then we have a final t cubed right here.
You should draw lines to connect.
Okay, from those three things we can see that we're going to simply add them together. Okay, we're going to add all of them together.
Jesus Christ.
Now, is there any t squareds? There's only one. There's only one regular t. There's one that's constant. There's one t to the fourth. There's one of them that's t to the fifth, and one of them is t to the sixth. So besides that, that's the only ones you can happen to combine here. Every problem is different. It's not always the diagonal. Okay? It's not always only three terms that you can combine. Sometimes you can combine a lot of the terms. So every problem is different. Understand? It's not always going to work out so that sometimes you can't combine any terms. That can happen. And you have to just write the whole thing out. But here, you're going to start listing your answer from your largest to smallest exponent, combining one step at a time. So start with the sixth power. There's nothing to combine with it. So you simply write 2t to the sixth. Then you go to the fifth.
Negative 4t to the fifth plus 4t to the fourth minus
Okay.
24.
Now, once I've done those three, thank you, Trayvon, you're right. We've done this one. We've done this one second, because this is the fifth, and this is to the fourth is third. Then combine the other three in your head. Okay, and we look and we see negative 10, negative 8, and negative 6 is negative 24. You're correct. So we have negative 24, t to the third. I'm just running out of room. You should write this all in one line. I'm just running out of room, that's why I went to the next line. You should be writing one horizontal line here, please. Next, I have t squared is positive 12.
Plus 12t, yeah, square. Plus 20t.
Minus
Oh, minus
20t.
20t, my bad. Plus 30.
Okay, plus 30. That is your voltage function, everybody. So, I'm going to write up the top V of t equals. Okay, again, notice I wrote at the top here, V of t equals. You're not just multiplying, but you're finding the actual voltage function. You're finding the actual voltage function here. Can you? No, you can't. There's nothing that says the same exponent here, Jay. That's a plus 30 at the end. That's not t to the third. That's a plus 30.
Oh no. That bad issue there, buddy.
Just look at the exponents. They're all different.
I'm thinking my bad.
All right, we've got 3 minutes to do distributive. Let's take a look. Distributive, I'm just going to show you. I'm going to let you do it on your own, but I'm going to show you what you need to do. Everybody remember foil? Imagine foil, but with a 3x3. You're just going to foil, so take a look.
Is that even possible?
It is possible,
I thought
John.
foil
It
could only be
is.
done with two.
FOIL is an acronym that just gives you a set of directions. If you expand those directions to like a third dimension, then you just continue. It's not another word, but it's
Your
FOIL.
mind's been blown.
They're not algebra 2. Algebra 3.
Remember, guys, come on, 3 minutes. Voltage equals current times resistance. The current is 2t to the third plus 4t minus 6, and the resistance happened to be t to the third minus 2t squared minus 5. Again, that's what I had for my voltage equals current times resistance. Simply, just like you do in FOIL, whether you guys realize it or not, you're distributing every term to every other term. So take 2t and distribute it to all three of them. Write your answer down. Write all three of them down after you distribute. Then take the 4t and distribute it. Take the 4t. I would use box, again, just for this simple reason here that this becomes very messy. Take the 4t distributed. Then, the key on the next part is you need to take a negative 6 distributing a -6 here. Take the -6, the entire quantity, make sure, and distribute it to each of these three terms.
That's good.
Once you've done all 9 of those, you have 9 entries, just like the box method. It's the exact same thing, but you're doing the box in your head.
You know what?
Okay, you'll have 9 entries when you do this. The same exact 9 entries you had in the box, you'll get the same exact answer.
Draw like from wars.
Is there
Okay.
a situation where one's going
Jeez, Jason, why do you have to think about it?
No, I would always use box, guys. I would always use box. Next page. We're not done with the problem. Remember, the problem then asked us, then find the current, resistance, and voltage at 2 seconds. Here's what I want to show you. If I have the current function, remember in the beginning I was defined I of t, and I was given R of t. Now, I also determined V of t. What I want you to notice is this. If you plug in a 2, if you plug a 2 in for t, because it's at a time equals 2 seconds here. If you plug a 2 in, and you do I of 2 instead, so you run a 2 through the whole thing, you'll get 18 for the current. And that's usually given in amps.
Oh.
Next, if you plug a 2 in for resistance, you do R of 2, meaning you plug a 2 into it. You're going to get -5, and this is usually units of ohms. Okay, it's a resistance unit. Now, the cool part is this. When you plug a 2 into the voltage function, so you do V of 2, you're going to get -90 volts. Now, the numbers are not what are important, negative or positive, because I know it's a little weird, but OHMS. What you notice is this. The original formula we were given in the beginning of the problem stated V was equal to I times R. That's what we were given in the beginning of the problem. If you take 18 times -5, you get -90. Okay, so you can have functions that are resistance and voltage and current. And you can evaluate those functions at certain locations and then actually just multiply them to get the answer. Or you can multiply the whole function like we did and plug in a 2 and still get the same answer. So again, what I'm showing you is that if you multiply these two numbers, like we see I times R here, you get the voltage. You actually end up getting the same number. Okay? What I want you guys to do tonight are 2 things. First, you're going to see that there's an example 3. I'll flash to it real quick. That's what example 3 looks like. There's a bunch of different steps I want you to practice. I put the answers in the notes. So please take a look, read through it, check your work, and then do your homework worksheet.
Oh.
Okay?
I'm gonna need.
Oh, it's Monday, isn't it? I'm
Yeah.
rushing. We have a few minutes still. We have until 50. Yeah, we have 4 minutes. Okay, we'll go to number 3 in a second. Okay, so everybody got this down?
Yeah.
Get up too.
Another 2 seconds. Come on, Jay.
Is it Monday to be sure?
Yeah, right, Monday's supposed to be shorter, but we get till 7:47, so I have another minute and change right now. Because we get 2 extra minutes because there's 5 minutes of announcements embedded into the morning. That's the way it works. All right. So, for this example, you're given 3 functions in the instructions. You are asked to combine them in some form or another. So, here, quickly, I'm just going to talk. I'm not going to do them. Here it's telling you to be quiet, first of all, please, and listen. Second of all, it's telling you to add these 3. Add all 3 functions together, but have a negative on the u. So add them all together, but switch the signs of u. Remember, add the opposite. The next sign says double all of the things in G, add u to that, and then subtract triple all of the h's, and so forth. On your way out, please get a homework worksheet. Practice tonight. Again, take a look at your SAT online and start navigating through there. I'm leaving the homework worksheets right here on the sink. Get one on the way out,
What I was
please.
going to ask you real quick today. We're